Every class you create in .NET inherits from the base system.object class. This is the basis for the entire .NET framework. As you saw earlier, the object class provides a number of members, and every class you write, as well as every class in the .NET framework, includes these members because each class inherits from object and has access to each member provided by the object class. You can, and often need to, override functionality provided by the object class. For example, the object class provides a toString method. This method lets you display some kind of text information for the object upon request. Generally, classes use this method to provide information about the current contents of the instance of the class. By default, the system.object's toString method simply returns a string that contains the name of the class. That can be useful, but oftentimes you'll want to override that functionality, and many classes do exactly that, because they can provide their own method that returns the contents of the class formatted as a string, something that better represents what that class is all about. Here's the documentation for the system.object class. And if I scroll down here to the methods, you can see that system.object implements a toString method, as I told you, and it returns a string that represents the current object. And I can click on that, and I can learn more about what toString does. And for a fairly simple method, there's some information there. It has some samples and so forth, and it talks about overriding the toString method. Okay, so it's very common to override the toString method. And you can do the same thing within your custom classes. In fact, it's really considered a good programming practice for any class that you create to override the toString method and use it to return information about the current instance of the class, the object instance of the class. So for example, in the case of a customer class, it makes sense to have the toString method return information about the current customer that's contained within that object. Maybe it would be the customer ID and customer name fields concatenated together. Maybe that would make sense. But it can be whatever makes sense for your application and for that object. Generally, you want it to be a fairly simple identification sort of thing, but you can include anything at all that you want within that, whatever's returned in the string from the toString method. Okay, so back over in the sample code here, have this sample method here, display toString. This creates a new instance of the class, passes in the customer ID, and once it creates the instance, sets the customer name to Maria Anders. And then finally, the method displays the toString, the value returned by toString. Okay, so I'm going to go ahead and run this. And I'll select I display toString. So this is the default behavior. Because the customer class doesn't override the toString method, I just get the fully qualified name of the class. Classes is the name of the project. You can see that up here in Visual Studio. And customer is the name of the class. So that's the default non-overridden behavior of the toString method. There are cases where that could be useful, but for the most part, it's not. So you're going to want to override it. Okay, so I'll quit out of that. And we can look at overriding that functionality. So I'll come over here to Solution Explorer, open up customer.cs, and what I'll do is go down to the bottom of the file here, and as you can see, I've already written that code, but it's commented out, so it had no effect when I ran the application. Okay, so this is a very simple example of how you can override toString. Most important thing here is that it's public, and I use the override keyword to tell the compiler that yes, I know there's already a toString method. I want to replace it with this method for the purpose of the customer class. I have to name it the same thing. If it takes any parameters, I have to match the parameter list of the version of the method that I want to override. ToString doesn't take any method or any parameters, so I don't have to pass anything there. And in this case, I'm going to pass in the concatenation of customer ID followed by the customer name in parentheses. So once I've added this to the class, essentially the base class, the system.objects ToString method, is invisible. There are ways to access it if you really need to, but that's kind of an advanced technique that we don't need to do here. Okay, so I've overridden that. I don't need to make any changes to this code whatsoever. I'll go ahead and start up the application again. Once again, hit I for display ToString, and because customer now overrides the ToString method, I get the information that I defined within my custom ToString method. So this has changed the behavior of that method. And again, I didn't need to change the calling code whatsoever. The other thing I want to talk about here is manipulating object references. The idea is that working with reference types is different than working with value types. So you have to either explicitly create an instance of a class or have a method hand you an instance of a class when you're working with reference types. You need to get an object reference somehow. And then in addition, the behavior when assigning value types is different than with reference types. Now, when you assign a variable that contains a value type to another variable of the same type, you simply copy the value from one to the other. For example, here's a method that displays that behavior. The method creates two integer variables, int a and int b, and initializes them to 10 and 0. And it displays the values beforehand. And then it copies the value from int a into int b. And then I change the value in int b. All right, so int b starts out as 0. Here it's going to be 10, and then it's changed to 15. This is a particular behavior. Each of these operations is copying the value, and the values of integer a and integer b are independent. So what I'm really doing here is that with this method, I'm demonstrating that when you make a copy of a value type, you're copying the data. That's the key idea. Making a change to the data in the second variable doesn't affect the data in the first variable. So I'll go ahead and run this. And hit J. All right, so I can see the before and after here. So I initially set them to 10 and 0. So they're 10 and 0. I copy the value of int a into int b. So at this point, int b is 10. And then I assign 15 to int b. The act of assigning this value right here doesn't affect int a in any way. And as you can see here, int a remains 10. Okay, so that behavior really is pretty expected. The issue is that reference types behave differently. When you copy a reference type from one variable to another, you're really copying the reference from one to the other. Both variables then refer to the same object in memory, and changes to one variable's members affect the other as well. It's a fundamentally different operation, and this is why I keep emphasizing the difference between value and reference types. So this is a demonstration of that different behavior. So I have this second method that essentially does similar things to what I did in the previous procedure with value types. But here I'm working with reference types. So the procedure creates two customer variables. And these are reference types. and it assigns a new instance of a customer to one of those instances. And then the code sets the customer name property of customer A, and then displays the value of that customer name property, or actually of the toString, which is now implemented. And so this is going to return the customer name as well as the customer ID. And then it's going to copy customer A into customer B. So this is the analogous operation to what I did right there, but that's with value types. So this is copying the reference. And so as a result of this, customer B is now going to reference the same object as customer A. And then I'm going to set the customer name property of customer B, the second variable, different from the one I changed here, to John Smith. And then I'm going to display what customer A is afterwards. Notice I'm not changing customer A directly here. I'm changing customer B. All right, I'll go ahead and run this, press F5, and hit K. And now you can see what happened. So here's the initial state of customer A. It's Maria Anders. Customer B and customer A now reference the same object in memory. Whatever reference customer B had before is now null. It was null to start, but if I had a customer reference here, it's gone and the garbage collector is going to clean it up, because these now reference this same object in memory. So by changing the customer name through customer B, I'm also changing the object that is referenced by customer A. And so here I'm executing the toString method of customer A, and it now says John Smith, because I have a single object in memory and two variables that reference that single object. Okay, so this is a very important distinction between reference types and value types. Make sure you internalize this, because this is going to be an important thing that you need to work with. Generally, it's very beneficial that reference types work the way they do, but it does have some gotchas. You can introduce bugs if you don't realize that you're changing the values of a single object in memory, and you have two variables and you think they're two different objects. So you do need to be careful.